What's up, man?
Hi there.
Hey, so I have two very easy multiple choice questions to see if you could get them. Very easy, very easy. So here is the first question. So I have three box trucks, and there's a bowling ball hanging with a string. So out of these three box trucks, one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these three, which one is at rest?
This one's at rest.
Yes, B. What would you say B is at rest?
Because the bowling ball is not moving.
Exactly. Yeah, exactly. Pretty easy. Which one's accelerating forward?
A.
Yes. Why is that one accelerating forward?
Because the wind goes this way. Like when you drive, the force of the wind comes like this way. Like you have force that goes.
But here's the thing: this air inside of the container, it's being actually contained from the air outside.
Say that again.
So the air inside of the box truck, for example, it's being contained. So it's being separated from the air outside. So when the truck accelerates forward, the air outside is not able to push the bowling ball.
Oh, you're saying the bowling ball is inside of
yes,
the
it's
car?
inside. Yes.
Oh, well, I mean, either way, I mean that's just the force of like inertia, motion,
yes,
gravity.
inertia. Exactly. So if you're inside the box truck, it looks like the ball swings back, right? It looks like it's swinging back, but in reality, it's the bowling ball is just being left behind.
Right.
So the whole container is moving, and the bowling ball is just being left behind.
Right.
Due to inertia. Exactly. You got it, because it resists the motion. So the second one's pretty similar, but instead of a bowling ball, it's a helium balloon. Again, it's inside of the box truck, the helium balloon. So out of these three, which one is at rest?
B.
Yes, for the same reasons as the first one, for example. Which one's accelerating forward?
Now this is a harder one, because I could say C just to say that I know something, but nah, inertia works the same way regardless. So so it should be A.
Actually, it doesn't. So in this case, because the helium is less dense than the air, the inertial resistance of the helium balloon is not strong enough to resist the force, I guess, of the air pushing. Because when you accelerate the container in that direction, for example, forward, all the air inside of the container is also being pushed in that same direction. Because air is more dense than helium, is able to push it in that same direction.
Beautiful. That's really
yes.
beautiful.
So buoyancy, it's an effect. It's a chain reaction of a force. So again, the medium that surrounds it, if it's more denser than the object, then it's going to push it in whatever direction the medium's moving.
That's dope. That's pretty dope.
Exactly. So, and I can demonstrate that here with this experiment here. There's a ping pong ball in here that's obviously less dense than the water that surrounds it. If I accelerate in this direction, what direction will the ball move?
You said go in this direction?
Yes.
Then it would go this direction.
Yes, and I can demonstrate that.
Yeah, that's
See?
cool. That's
because
really
the water's more dense.
Yeah,
obviously.
so what is tell me about this. Like, tell me your purpose for this.
So I'm getting to that point. So here, let me show you this. Since we understand buoyancy always follows the direction of the force, I did this experiment in a cargo van with a helium balloon and an apple. Again, it was inside a cargo van. So since we understand helium always reacts in the same direction as the force, what direction would you say I accelerated? To the right?
This way.
Yes, you got it. Again, matter doesn't lie. You know, not only does it show you when I applied the force, it shows you the direction I applied the force. You know, so I did it in a smaller scale just to prove the point. Here, I'll show you this one. I did it like in a smaller container with a ping pong ball and a steel ball. So what direction right here would you say I accelerated? To the left, exactly. Again, matter doesn't lie. So perfect. So one more, pretty similar to this, and then we'll get to the point. So right here, I was holding a container like this with a ping pong ball and a steel ball like this. I was holding it at rest, but I only accelerated one down out of these two.
Okay.
Which one would you say I accelerated down? The one on the left or the one on the right?
Well, it'd be the one on the right.
Yes, because that one shows the reaction. You know, the ping pong ball gets pushed down and the steel ball gets left behind because the whole container is moving down. I'm accelerating it down, right? Let me ask you this. If I'm holding the container like this and it's at rest, and I release it into free fall, do you believe gravity pulls it down towards the earth?
Pulls what down toward the earth?
The whole bottle and everything inside. Do you think when I release it, you think the bottle accelerates down towards the earth from being at rest?
I think that so part of that gravity test, or part of what we learned in physics or whatever, chemistry, was that it's not about acceleration per se, right? When it comes down to the fall of gravity, because gravity is like inherent. Like
they do claim 9.8 meters per second, which is an acceleration.
Yes.
Which is an acceleration.
Yeah, which is an acceleration, but it's but the pre-existence of gravity creates like the circumstances for that to happen. That's what I'm just saying. Like in terms of like, I don't know. the credence that we give to the acceleration of gravity is more so an observation or analysis of the nature of gravity rather than like an actual acceleration. Because you would think an actual acceleration is when like you push that pedal and you go, as opposed to, you know, we have no control over the acceleration of the gravity. We can create parameters to like affect the gravity like they do with like NASA or whatever, and you have like zero gravity. But this Earth, right? Like, yeah, I wouldn't say that the gravital acceleration or whatever is like an acceleration per se. It's inherent. Like it's a So
well 9.8 meters per second. It's 32 feet per second. You know how long 32 feet is? You know, 32 feet is a pretty long distance. To be able to cover that in 1 second, I would say that's massive acceleration.
For sure.
From 0 to 32 feet per second, it's pretty fast.
It's massive displacement. It's massive displacement.
Yes, and that's why matter reacts, because it displaces. Exactly.
Okay.
So here's the thing. The one on the left was actually free fall, but we see no displacement of matter.
Beautiful.
Matter doesn't react to acceleration in free fall, because the reality is that objects don't accelerate in free fall.
Wait. What are you saying?
So the one on the left, obviously I just released it, but we see that matter, the ping pong ball and the steel ball, didn't react. They remain in the relative positions, relative to the bottle. So they didn't react like this, like they should.
But what are you? Oh, because this is a throw.
This is a
throw.
It's more than a throw. I was holding it and I accelerated like that.
Yeah.
So it was a physical acceleration, and matter reacted to that.
Oh.
In free fall, they claim that there is a physical acceleration of gravity, but there is no reaction of matter.
So that makes sense.
Yes.
That makes sense.
So here's the thing. I don't know. You obviously know that gravity is just a theory, right? Okay. And what that means that gravity has never been physically measured. It has never been physically proven, and that's why it's a theory.
Okay.
So the fact is, we understand helium follows the direction of the force. You know that the direction of the force moving, right? If I have a helium balloon here on Earth and I release it, what direction does it go?
Well, it goes up.
Exactly. Why does it go up?
Well, I mean, I'm not gonna act like I know, but you know.
Why do you think it goes?
But if we're considering again the parameters that we're talking about that allow this to happen, it's because it's lighter than the rest of the air around it. So because it's less dense, then it just it's gonna go toward less dense. The air is less dense.
Less dense the higher you go.
Higher we go.
So can we say that the air is pushing the helium up because the air is more dense?
Can we say the air is pushing the helium up? I don't know. I wouldn't say that.
What's pushing up the helium then, if not the air?
I wouldn't say that. I mean, if I had to say, I would probably say the relationship. So like it's like the relationship between the things. So yeah, like I said, right? Like they say, there's less dense air. Yeah. So the lesser densities, it's gonna go toward the lesser density. I mean, we see with like attraction, right?
Yeah.
So it's like the relationship more so than like trying to like say it in that way. Like to say that the air is pulling it up. Nah, I think it's just going toward where, aligning with this. Again, it's lesser dense and this is denser air. So it's gonna go toward
towards the less dense. But here's the thing. Like in this experiment I was showing, in order for the helium to react with an environment like air, for example,
there has to be a force.
There has to be a force. And that force affects the air, which then affects the helium. So the air is obviously affecting the helium, but what's affecting the air to be able to push the helium? That's the question.
Well, remember that gas travels up too.
Yes,
heat
there's a reason why though.
Yeah,
there's a reason.
You've done this shit.
Yes. So let me show you one more thing before I get to the main point, because you just said gas rises up, and I can show that here as well. Flames, when they're contained, like a flame, if you have a flame like a candle, the flame will always react in the direction of the force. It will always get pushed, because it's less dense than air, in the direction of the force. So here, let me show.
Oh.
Yes. Yes. So right here I accelerated. What way did I accelerate, would you say? To the right or to the left? What direction did the flame act?
I have to know. It's going to go this way.
Yes, so I accelerated in that direction, because the air is more dense. When I pushed the container in that direction, the air pushed the flame in that same direction. So here's the thing. So the air obviously has pressure. In order for the air to have pressure, it requires a force. So they're telling us that when I release this object, it accelerates down due to gravity. But the fact is, because the fact that there is no measurable force in free fall, the force is only measurable when you're connected to the earth. So when you release this object, it's the earth that comes up to meet it, not the object that comes to meets the earth. So right now, because you're connected to the earth, the force of the earth is actually a push, not a pull. So the earth is literally pushing up against you, and that same force was compressing the air, so it's pushing up the air, which then is able to push up the helium balloon. Same with like the cargo experiment. What the Earth is literally pushing up the air, which is pushing up the helium and all the lighter gases as well. So that's what gives us our orientation. It's the force of the Earth, but it's a push, not a pull. So the Earth is literally moving up right now. And that's the reason why we are stuck to it, because it's constantly pushing up against us.
Well, what's the difference between calling this a push and calling this a pull?
Well, that's the thing. Pull, they claim that the Earth doesn't push up, that it pulls things down. That's the pulling force of gravity. That's how they explain us sticking to it, right?
Okay, good.
So the reality is, again, you believe the Earth is a ball, right?
I don't really.
You believe the Earth is a ball, or what's your stance?
That's what they say. I'm not an astronomist, or like I don't, you know.
So you wouldn't say it's 100% a ball then?
Yeah. I mean, that's been said too. That it's like oblong. It's not. It's
oblate,
not precisely.
spheroid. Okay.
Yeah. Spheroid.
Okay.
Yeah.
But here's the thing: if we could prove, that the Earth is literally pushing up, and buoyancy shows us that without a shadow of a doubt. If we could prove that the Earth is literally moving up, and up is relative on a ball, in other words, if you're standing here, up is this way, but if you're standing down here, up is in the opposite direction. In other words,
no, I don't. I disagree with that.
So you don't think China's up is different from our up? If we live on a ball,
they say that. I've heard some people say that, but nah. Again, it's relationship. Like to me, because if you're here and this is up, if the ball's still like this and you're down here, this is still up.
Yes.
You feel me?
But if you're down here, if you have a person right here and a person, let's say on the side, their up is perpendicular to their up.
No. Not if the ball is in the same orientation. So like if you have people even on the side, this is still their up. Like this, people down here, this is still their up. But once it goes like this, then this is the new up. These are the ups.
Yeah, I get you. I get you. If you're standing up here, then your up is this way, regardless of anybody standing over here. But if you're standing here and you have somebody standing here, their up right here is this way.
Okay, again, like that's relationship.
Yeah, relative. It's relative.
It's relative. But in reality, though, like if we assumed a static position of the ball, this will always be up no matter where they are. So it doesn't matter. Even if we had China on the top, right, and we were just looking at the Earth from it would all be up. And if U.S. was down here, this would still be up. But if we weren't American, if we were in U.S. or if we were blah, blah, then yeah, of course, it's going to look like wherever we are on the thing. But no. If we're taking like a holistic view, then wherever it is and wherever we're standing, like this is what Einstein said. The general theory of relativity is the speed of light is the same for every observer, no matter where they're standing.
Okay.
So if the speed of light is the same no matter what for each observer, that's just all about perspective. So where you are, that's going to dictate. You know what I'm saying? Like
you're up.
Yeah, you're up. Or excuse me, the up. And so if I'm standing on the outside of the thing, then I dictate, or like my perspective is going to dictate the ups. But yeah, you can have your own ups, or you can have your own lefts and rights. You know what I'm saying? Like depending on where you are, especially because
on where you are. Yes.
Especially because you're in the context. Especially because you're in the context. Please go ahead.
Yeah. So again, if you could double check this, with people that like Einstein, I'm pretty sure he would concede that up is relative on a ball. In other words, it depends where you're standing.
Where you are, yes. I agree with that.
Yeah, exactly. So here's the thing. If we could prove that the Earth is pushing up against you right now and not pulling you down, and it's literally the ground moving up, how can that work from a globe? How can the Earth be moving up in every direction simultaneously if it was a ball? How can the Earth move up if it was a ball?
And this is what I'm answering. So, because again, it's in a position,
because up will be the opposite of down, which will be the claim of gravity, because gravity pulls things down towards the Earth, right? So up would simply just be the opposite of that. Up is the opposite of a pulling force of gravity.
Yeah, but you know that space is separated from
outer space is a different reference frame. Space.
Yeah.
But here's the thing: if you're in outer space, you technically just float, because there's no forces acting on you, so you have no orientation. Mm-hmm. So you could be upside down.
But not everything floats in space, though. Not everything just floats.
If there's no forces acting on you, then you have no orientation. You require a force to give you orientation. That's why I'm saying.
Say that again.
In order to have orientation, you need a force to dictate the orientation. That's what I'm saying.
I disagree with that.
On a ball,
I think you have to exist. You have to be an object first to have orientation. Like you can't have orientation if you're not an object to begin with.
Well, that's what I'm saying. When astronauts are supposedly floating in outer space, they experience zero force. So they don't experience orientation. Like if they're upside down, their blood doesn't rush to their head. and stuff like that. So everything's just neutral. There's no orientation if there's no forces acting on you.
That, I mean, again, like I said, that might be a like a meticulous, meaning being picky about where you're deciding to perspect, like where you're deciding to observe. But the reality is that they are also interpreters, right? They are also observers. They also have their own perspective. So they couldn't even have perspective or orient anything if they did not exist to begin with.
Yeah.
So you have to have the, like, even the existentialist, right? You have like Sartre, who says he says existence precedes essence. So you have to exist first.
Yeah, exactly. To be able to perceive information.
Yeah.
Exactly.
So I wouldn't say that just because you have zero gravity, or just because, like, again, like you're floating through the atmosphere, that, there's no orientation. Because no, there is an orientation. Following along with what you're saying about the Earth, like, yeah, no. I can definitely fathom that there is something that is pushing the Earth. I see what you're saying. Like it could be possible that something is pushing the Earth up, even though it rotates, right? Even though it revolves.
Sure.
But it's from a particular, and then the Earth has its own atmosphere,
Yes.
where that has its own it's its own relationship, it's its own, to the other objects.
Well, again, I would say the atmosphere here on Earth is subject to the orientation or the force of the Earth, because you only experience orientation when you're connected to the Earth, in other words. So if you were connected to the Earth and you were hung upside down from a tree blindfolded, you will know you're upside down, because, again, your blood will just rush to your head.
You said you would know, okay.
You would know, even if you were blindfolded. If you were turned upside down here on Earth, you would know.
Being a subject of the Earth.
Yes,
and
being within the Earth.
Yes, okay.
Now, if you're in outer space, for example, in a space station or whatever, and you blindfolded you, and they turn you in upside down, for example.
From their perspective,
in that you won't know.
You wouldn't
that you're
even know,
exactly, because there's no forces acting on you.
Yeah.
So again, you require a force to give you orientation, and Earth does have orientation. The problem is that they're telling us that the Earth is a ball, but if we could prove that the force of the Earth is a push, in other words, it's literally pushing up, from a ball perspective, that wouldn't work, because that would mean the Earth will have to be expanding. It will have to be growing to be able to push up in every direction at the same time.
Wait, what? Oh shit! I think I know what you're doing. You're saying, wait. You said if the Earth was a ball, then if it were pushing up, it would have to expand?
Yes.
What do you mean by that? Like, from the center, it'd be expanding?
It would be expanding from the surface and everything. It would just have to be expanding to be able to push up this way, and at the same time.
Rather than, you mean rather than the ball just moving on its own?
If the ball was moving on its own in one direction, for example, just this way, then it's only pushing up in this for the people that are here. But if you're standing here, it's not pushing up; it's leaving you behind, if anything.
Okay, but do you think that the Chinese know that, or feel that they're going like a down instead of an up?
Well, it's relative,
because their gravity doesn't work differently from our
exactly.
gravity.
Yeah, I'm getting to the main point. Here's the thing.
Yeah.
From a baller perspective, it wouldn't work if the Earth was pushing up, because, again, it would just expand and it would just explode. The reality is that orientation here on Earth is not relative; it's actually singular, which means everybody experiences the same orientation.
Okay.
Which means the Earth is actually a level plane, and we're all standing on it, and everybody's up is the same. So the Earth is an extended plane. It's not a ball.
But if everybody's so are you saying that everybody's up is the same, or it isn't?
It is,
because you're making the stress that if China's here,
that's if you believe the Earth is a ball. It wouldn't work.
Oh, okay, that's what you're saying.
Yes,
okay,
it wouldn't work.
So go ahead. So singular.
So the fact is, orientation is singular, meaning we all experience the same up and down, and everybody here on Earth is on the same level. In other words, so we're all experiencing the same orientation. They're trying to tell us that orientation is relative, but again, it wouldn't work if we could prove that the Earth is literally pushing up, which it is. Physics shows us that the Earth is literally pushing up. So this will be the number one proof to debunk the globe Earth, is the fact that gravity is not a pulling force, it's actually a pushing force. And that's why, in order to believe in the ball Earth, you first have to believe in the pulling force of gravity, because that's how they explain how people stick to the ball and how everything just sticks to the ball, because they claim that it's a pulling force that just goes towards the center of the Earth.
But are you still calling this a pushing force?
No, things don't go down towards the Earth. They don't get pulled down towards the Earth.
No. But in your analogies of like free falling the bottle, or even free falling the ball, right? It'll still go down. So are you calling that a pushing force?
No,
or are you calling that?
That's my main point. So the Earth pushing up, the air is able to push up anything that's less dense, like a helium. That's why the helium balloon rises, right? Now, when you have a more dense object than air, the air is not dense enough to push a more dense object like this.
Like it doesn't have the force.
Exactly, it doesn't have the force necessary to be able to push this up like a helium balloon because this is more dense in the air.
Okay.
So the air is just literally moving up through it because the Earth basically comes up to meet this.
Interesting.
So this never moves down to the Earth. It's the Earth that moves up to the objects in free fall.
Okay.
Due to inertia.
Okay.
Again, it's just being left behind. Same thing like with like the bowling ball example. The whole container is moving, but the bowling ball is being left behind because the air is not dense enough to push it like the helium balloon. So here on Earth, we experience the same thing. When you have a helium balloon, again, it rises because the air is dense enough to push it, but the air is not dense enough to push something that's more dense. So the Earth just catches up to it again.
Okay.
So this just slows down and it doesn't accelerate down. Does that make sense?
It just slows down.
It slows down.
Being more dense?
Because it's more dense in the air, and the air's not able to keep it up, keep up the force. So it just starts to slow down. But because we're also moving up with the Earth, it looks like it goes down. Visually, it looks like it goes down, but physically, it's not. Physics shows that the Earth is literally pushing up, and it just simply catches up to free-falling objects. So that's the reality. And again, that wouldn't work from a globe Earth perspective, because that would mean the Earth would have to be expanding to be able to push up in every direction at the same time. So that's why they require people to believe in the pulling force of gravity first in order to introduce the globe Earth concept. Because that's what it is. The globe Earth is just a concept. It's not based on actual practical physics. So the fact is, again, the Earth is a level extended plane. And a lot of people would ask, well, wouldn't you fall off the edge, right? A lot of people say that. The fact is, the Earth, in my opinion, based on physics, it's a contained system. Why? Because we experience here 14.7 psi of air pressure at sea level. And obviously it decreases the higher you go, right? In order to maintain air pressure, you require a solid barrier, a solid containment. So in my opinion, the Earth, the air here on Earth, the atmosphere is being contained by a physical barrier, in my opinion.
Absolutely.
But they're trying to tell us that it's gravity that's maintaining it. This pulling force of gravity is what's holding the air in. But again, the pulling force of gravity has never been measured. That's why it's just a theory. So
it's not, well, we know how stubborn science gets with like certain axioms, right? Like certain proofs. Because like even
you guys can give this a read if you want on the side.
Let's consider, right? Just the mere fact that they could even go ahead and measure 9.8 seconds per second. Yeah. That is a measurement.
Yeah, that's a measurement.
And it's a measurement that has also objectively helped us to solve to figure out certain things about living.
Yes.
So regardless, there's it's not that there's no credence that can be given to the theories that are offered, right? But here's my question to you though. What does this gain us?
Well, do you think understanding the nature of our reality and our existence is important?
Of course.
So that's what it comes down to. So by believing in a false premise, like the globe Earth, for example, you fall into this rabbit hole of just believing ideas about what this universe actually is and what you are within it. So you basically fall into a religion. So you just start following experts, on the subject that you think are right, but in reality they're not. So they're just it's basically just a religion to control people, because all religions, in my opinion, are there to control people, and the heliocentric model is the biggest religion on Earth. So it's all about controlling people's minds, and that's how you control people's actions, by making them believe something that's not true.
How is it a religion?
Because all religions are based on faith, for example. So the difference between religion and science is that science is measurable, testable, and repeatable, meaning you don't have to believe it, you can just understand it. Religion, on the other hand, doesn't have that. You have to literally believe their claims because it's not backed by practical physics. For example, Jesus walking on water. That defies physics, but people believe that happened. But that's just a religion. People just believe it. Just like the globe Earth, people just believe that it's a ball, even though it defies physics. So people just blindly believe it.
Okay, but what's the difference between what heliocentrists believe versus what people who believe that Earth is the center, or who have other beliefs? What is it that they are teaching that other people?
Well, they're teaching things that go against common sense. For example, buoyancy, always following the direction of the force. They're saying that gravity is the force acting down, but helium goes in the opposite direction of that, which, again, is a contradiction of our everyday experience and what we can recreate here on Earth. That buoyancy will always follow the direction of the force because obviously it's less dense than the medium that surrounds it. And based on the direction that the medium's moving in, the less dense objects are going to follow that same direction, because matter can't move itself. It requires an external force to be able to move matter, because matter doesn't move itself, it's inanimate. So again, physics shows us that the force of the Earth is actually up.
It's inanimate, it's inanimate, but the inanimation is more so right. I mean, would you agree that inanimation is more so about a lack of autonomy, more so than?
I would say you require some kind of force to move inanimate matter, because our bodies are inanimate, but we have a life force in us that basically moves our bodies. So we have some kind of force that powers our body. Everything that has motion requires a force, like boats, airplanes, helicopters, cars, everything. Even the leaves moving here, the air is what's pushing it. And what's moving the air? Well, the different temperatures here on Earth. Air rushes into the lower pressure, and that's why air flows, right? So it all has to do with pressure.
Pressure goes into the lower pressure, and that's why it flows?
Yeah, so when air, for example, when air flows and pushes the leaves on the tree, the air is flowing because there's different temperatures here on Earth, and it's not all exactly the same temperature.
Yeah.
So the air will always rush into the lower pressure areas because there's a change in pressure. So everything that has motion is my point. Like right now we're feeling the air moving, right? Everything that has motion, it requires some kind of pressure, which is a force, which requires a force.
Sorry, I just want to make sure I understand. So, like, what difference do you think that it makes whether we are oriented to believing the heliocentric theory versus believing I can't remember the Earth-centric.
Geocentric.
Thank you.
Yeah. So again, the biggest difference, in my opinion, is first that people that believe in the heliocentric model, in my opinion, don't trust their own common sense and discernment. So basically, to me, it just shows that you just rather believe someone than understand things for yourself. That's one for one. So you're basically mentally handicapped at that point. Another reason is understanding that the Earth is geocentric kind of points to the direction that this place came from something. So it was a creation of some sort. So
Whoa, which one does that? Which one does that?
So the understanding that this place is geocentric kind of points in the direction that this is a creation of some sort. Because even the first law of thermodynamics claims that energy cannot be created nor destroyed. It can only transform from one form to another. So something cannot come from nothing. You know, it already kind of has to exist in a way, so then be able to create something from it. So we're experiencing something here, obviously. It's some kind of intelligently designed place, which obviously didn't come from nothing.
Yeah, but you know the theories of heliocentricity and geocentricity are about the revolution. It's not about whether the Earth is round or flat. The heliocentric or geocentric theories are about whether the Earth revolves around the sun, or if it has its own, or if the sun revolves around the Earth.
Again, like I was saying earlier, how the heliocentric model or the ball Earth relies on the theory of gravity for them to be able to present their explanations about the universe. These orbits that you're talking about, again, they rely on gravity as well. They're claiming that gravity is what creates orbits and all of this, and the mass of the object making the other object.
Interesting.
But all of that's just made up. It all starts from a false premise that gravity is a pulling force, because we can all test here on Earth that the Earth's force is a push. You know, and again, if we could literally physically prove that, then the whole heliocentric model falls apart. The whole.
I do want to warn, because these are very intimate details, and that's really good. You know, you've done your research. But the heliocentric model actually stems from the invention of the astrolabe. The astrolabe is an invention from the African culture, Islam. They are the ones who gave them, who provided the device, developed and provided the device to even give them the ability to see whether, you know, the sun revolves around the Earth or the Earth revolves around the sun.
Are you talking about making predictions about the stars?
No, I'm talking about literally like Galileo. Like Galileo got his information using the astrolabe, which Africans created. So you could even be able to look at the stars and be able to look and see and have that type of perspective to make the observation. Now, and in terms of everything else, like in terms of whatever gravity and how all that type of stuff, those are like more intimations, right? That's more intimate details.
Sure.
But the actual observation that the Earth revolves around the sun is an observation that was made through using a physical apparatus that was literally created by.
Sure, you're using a physical apparatus to make an observation. So you're not making a physical measurement, you're making an observation, like you said. Here's the thing though, they're saying that because the sun appears to move in the sky, that it's actually the ground that's moving and the sun stays in its relative position, right? That's what they're saying.
I've never heard that. I've only heard that the sun goes up and down, or that it rises to the east and the west and it travels, you know, east to the west. I've never heard that the ground comes up to the
Okay. No, you kind of misunderstood me there. So people, you're saying this instrument that they made to observe the sun, they were able to observe that the Earth rotates around the sun, right?
Yes.
That's what you said. What if it was the other way around? What if it was the sun rotating above the Earth? And
remember, they thought that already.
Yeah.
They thought that already in thinking, you know, the things that they thought. But the instrument allowed them to make the actual observation. And so much so because it helped them as well to orient themselves to be able to make certain expeditions. Like, we are the reason why they found a place like America in the first place, right? Or other more distant places.
Sure.
Because it gave them the ability to take the risks, to take the risk, because then they had a better navigational sense. So, you know.
So again, making predictions about where the sun's going to be tomorrow at a certain amount of time, you know, that's what they were able to do. Is just to make predictions, you know, based on the location of the sun and stars, I guess. Because obviously navigators used to use the stars to navigate, and obviously the sun to navigate back in the day. But using the stars and the sun to navigate, in my opinion, doesn't prove whether it's a globe or not. Because you could do it from a level surface as well, and if the Earth was way smaller, rotating above the Earth, you can make the same predictions.
Yeah. But I'm not. Yeah.
So it doesn't prove either or, is my point. These observations of the sun doesn't prove whether it's a globe or a level.
Yeah. And again, bro, like I said, I can't even address that because I don't even have a position on whether or not the Earth is a globe or if it's flat. Okay. But like I said, but in terms of the heliocentricity, just simply as the Earth revolves around the sun, or that everything revolves around the sun, that is an observation that was observed through creating the means to do that, and then it's made sense and helped to create.
I would say, in order to even take that observation like serious, you would have to observe it from outer space to be able to see. Now you can see the Earth moving around the sun.
Yeah. So how do you feel about that then? Seeing like SpaceX and you know.
Yeah, everything about outer space, in my opinion, is just Disney for adults.
Word.
So here, let me tell you why. I'm not just gonna say that.
I don't blame you for thinking, because I see that too.
Yeah.
I feel like it's overblown. We got to fix the shit here first.
Yeah.
You know what I'm saying?
But here's the thing, though. Here's how I can easily debunk all of these space expeditions and all of that. In order for an airplane or a helicopter to take flight, I don't know if you knew, helicopters, for example, have to push off of the air to gain altitude. So the propellers are pushing off of the air, and that's how they're able to gain altitude. In order for that,
are they pushing this way or that way?
Yeah, they're pushing up. Obviously,
Yeah.
They're pushing up against they're pushing down on the air, but then that gives them the lift. And my thing is that in order to be able to push off of the air has to be at a certain density. That goes with airplanes too, as well. So the higher you elevate, the less dense the air is.
Yeah.
So eventually you're going to get to a point where your propellers are not going to be able to push off of the air anymore because it's not dense enough.
Okay.
So physically there's a limit to how high we can fly.
Yes.
Because the air density changes. It becomes less and less.
Correct.
They're claiming they're going into outer space, which defies physics. Again, there's actually a height limit of how airplanes and helicopters fly. But they're claiming that you're going beyond that, which defies physics.
Right.
You know, not only that, the fact that air has pressure here on Earth tells me that it has to be physically contained somehow. They're claiming outer space is a negative pressure system next to the Earth pressure system without a solid barrier separating the two, which defies physics as well. Because in order to separate two different gas pressures here on Earth, you need a solid container. Like if you have an air pressure machine, the air inside that air pressure needs to be fully 100% contained, because if there's a tiny little hole on that air pressure machine, what do you think is going to happen to the air inside? It starts to rush out.
True. Although, again, you're talking about containers.
Yes.
So if again, dealing with containers, we have context. So like, even if there's a hole in a container, we can also create a container inside of that same container that has a hole in it. Like, so you can never stop having containers, and they're gonna have their own.
Our body is a container, you could say, because our body internal temperature and our internal
yes.
pressure is different from the outside.
Absolutely.
Yes. So yeah, we have a container, in my opinion, within a container, which is the Earth, which could be within another container. We don't know that. My point is that nobody's been outside of the Earth system to be able to claim what it actually looks like as a whole, because in my opinion there's a limit to how high we can go, which means there's a limit to how much of the Earth we could see at once. They're claiming they're getting a bird's eye view, a God's eye view of the entire Earth, which you know, it's ridiculous. That's why real photographs of the Earth don't exist, and NASA admits all of their photographs that they show us, they're all CGI. Exactly. And every space agency would admit to that. And even if they claim they were real, in my opinion, more based on facts here on Earth, they're bullshit. Because if I showed you a picture of me flying or a video of me flying, would you believe I could fly? Like if I showed you a video of me flying, like Superman.
Like Superman?
Yeah, would you believe I could fly? And then
if you wanted to show me, if you want, I don't know. It depends on the time. First of all, like whether because I'm sure you've seen like the people who've been able to like harness their chi now and shit and like move stuff, use like telekinetic forces or whatever. They're channeling into those things or whatever. But no, if you wanted to, if you endeavored to prove a point to me that you could fly and you wanted to show me a video that you could fly, I think I would be more content, especially if we're in the same physical space, for you to just do it in front of me rather than show me.
Exactly. You want to see it for yourself in person.
Right.
You wouldn't take video as proof then that I could fly. Like if I told you that, I can't do it right now.
Especially not. Yeah, I can't do it.
I'm tired right now. I can't do it.
Yeah.
But here's a video.
Right.
You wouldn't believe it, would you?
Yeah, no, it'd be harder now.
The reason why I wouldn't believe, claims like that is because that claim, in my opinion, defies physics. So same like if you showed me human beings flying, defies physics, because we're obviously more dense than the air. We're not be able to lift ourselves. The air
are more dense than the air?
Yeah, we're more dense than the air. So the air can't lift us.
You mean in order to fly, we'd have to be more dense than the air? Or
no.
I mean less than that. Or we are
already more dense than the air, which basically prevents us from flying. So when a bird flies, I don't know if you knew, when they expand their wings, they're increasing their surface area, which then basically makes them lighter relative to the air. So when they flap the wings, they're able to lift themselves because they're expanding their surface area, and they're able to push off of the air to fly. That's how birds fly. Mm-hmm. Exactly. Mm-hmm. Humans, we don't have that ability. We don't have wings. We would need super giant wings to do that. But a human being without any wings or any external, components wouldn't be able to fly. And if you show me a video of you flying like that, and obviously I know it's bullshit. So just like if you showed me a video of you walking through a wall, we know matter can go through matter. Two pieces of matter cannot occupy the same space at the same time. That's a fact. That's even mainstream science would admit to that. So again, if anybody shows me a video of somebody walking through a wall, walking through a tree, that defies physics. So I would definitely not believe that. That's like X-Men physics there.
So let me ask you then this too. What's your name, brother?
My name's William.
William.
Yes.
William. I'm Despues. Nice to meet you.
Despues. Okay.
Why do you say you're a fifth grader? Are you the fifth grader?
No. This is fifth grade logic.
Okay.
Understanding buoyancy, for example, and inertia. A child can understand these concepts if you explain it to them and demonstrate it to them.
Yeah.
They'll understand it. And they'll be able to answer the correct answer next time you ask them a question.
Yeah.
So.
Yeah. But I want to make sure that because again, like my dad does this too. My dad is like a flat earther. My dad is like he does the whole thing.
So you're in the middle, would you say? Says you don't believe the globe, or you lean more towards the globe?
I'm trying to figure out the relevance. I'm trying to figure out what is the point?
Well, the point is about control. Because again, if you believe the globe Earth, for example, 100%, then you're willing to throw away your common sense in favor of an image, for example, that they show us on TV and on movies. So you become more susceptible to just do what you're told at that point. So you're going to accept a rigged economy now. You're going to accept rigged politicians. You're going to accept all of this and just go along to get along because that's what everybody believes. So it's like a cheap shot on our common sense. That's why globe versus flat matters. But here's the thing, the Earth is not flat either. I guarantee you, your dad, you said, believes the Earth is flat. The Earth is not flat either.
I don't think he doesn't think it's completely flat, but yeah, he definitely doesn't think it's
No,
flat.
and I'm going to tell you why. Because the Earth is actually level, and there's a huge difference between level and flat. So I'm going to tell you real quick. So flat, the definition of flat is simply a surface without any bumps or indents. So it's a smooth surface. So you could have a wall that's flat. You can have a slope that's flat, right? You can even have a ball that's flat. The surface, the surface of a ball can be flat because it doesn't have any bumps. Level, on the other hand.
You're being too technical with that definition.
No, I'm just being technical. Yeah. Level, on the other hand, level is an orientation that's perpendicular to the vertical, which is the force of the Earth.
Yeah, okay, that makes sense.
But it's not a pulling force. The force is not acting down. It's actually acting up. So that's the big psyop.
And it's only acting up because of the orientation of the Earth.
Yes, because the Earth is pushing up against you. That's what gives us our orientation. That's the force that gives us our orientation. And that's what makes Earth level, because the Earth is level perpendicular to its force.
So what I'm asking, though, is how does our knowledge base change out of knowing that the Earth is level as opposed to being a globe? I say that because, like I said, obviously, whether or not the Earth is round or flat, we can meet from the same plane, right? And
Sure.
we can observe the same things and understand different things, even coming from different experiences and everything. The orientation of the Earth, the shape of the Earth or whatever, doesn't really matter as far as, like I said, out of what
Sure.
so I'm like, how does the information, how does our knowledge base change? What kinds of things change when we think, oh no, the Earth is
a level and not a globe.
Yeah, not a globe.
Again, like I said before, it comes down to, you wouldn't want to be in a religion or a cult, would you? Like blindly, would you want to be in a cult? Like following a false belief,
just keep going.
right? Nobody would want. Let's just be real. Anybody that's like truly aware wouldn't want to be in a cult, especially blindly, right? Because in my opinion, people are in cult willingly. Like that is what I would call a religion, like Christianity. Again, that is a cult in my opinion. That's just my opinion. I know people are gonna get triggered by that, but that's just my opinion based on how cults behave.
No. But I know what you mean. It's investment because it's investment.
Yes, exactly. And people willingly. Now, if you were unwillingly in a cult, I would say that's even worse. Because you're not even aware that you're in a cult, but you're following these teachings that everybody else inherits, and you start living a false life. You're not living a life that's true to you, who you are. So that's why it matters. Because once you understand that the globe Earth is physically impossible, and you accept the facts that the Earth is a level plane that's pushing up, then you start to get your common sense back. You start to think for yourself. So it separates people thinking for themselves and people just blindly following.
Absolutely.
So that's why it matters.
Absolutely. But so I'm gonna pose this.
Yes.
So we have this time.
Yes.
Where at least for the past, probably about 10 years, but almost 10 years, I would say, almost 10 years, we've been pushing this idea of the fluidity of gender, right?
Oh my God, yeah.
And so you have like things like this, and you got kids believing, oh yeah, it's okay, we can have like all of these, multiple things. But then they come to see and realize the mountain of work that we've already done in terms of being able to notice that, there's the distinction between male and female and whatever the qualities are, and realizing that, okay, hold on, wait a second. And then they just have their, because then they have certain experiences that, just challenge, right? Like
sure.
what they see, perhaps involuntarily or unsolicitedly, but
sure.
Regardless, the point is that knowledge comes to itself and comes to attack them. But they didn't need, but either way, they didn't need a doctrine of fluidity of gender, or the only need, or the doctrine of or doctrine, but the reality of there only being two genders for them to know and realize, oh no, there are only two genders. Like there's only male and female. So in terms of heliocentric versus geocentric, or not even that, because your point isn't really the heliocentricity or the geocentric. It's really about the shape of the Earth, right?
Yeah.
So I'm saying, so I'm like, whether or not the Earth is I'm wondering, well, what is it that is in the shape of the Earth that matters, right? Where that's going to change, right? Like our knowledge base, because people believing that they can be anything. I mean, consider how many of the kids, but people in general who regret being like, oh, I want to try to be the other gender, and I'm taking medication, and I'm doing mutilation, and I'm all of this.
Well, here's a huge difference between that, and I'm going to highlight the flaws in that. Yeah. When it comes to like gender identity, for example, gender identity, in my opinion, is subjective. It's how you feel, right? It's a feeling. It's not really objective. It's not something you can physically prove, right? Because objectively, there's male and female. That's it. Objectively, you either and I'm an objective kind of person, so I just go with the objective. When it comes to the shape of the Earth, the globe Earth is not objective. It's kind of like the gender identity thing. The globe Earth only exists subjectively in people's minds, because that's what they were told as kids. That's what they were shown in a cartoon, in movies. So the globe Earth only exists subjectively. Objectively, however, physics, practicality shows that it's impossible. That the Earth is a level plane, extended level plane that's literally pushing up. So that's the difference between objective and subjective. So I go with objective, what I can prove to myself. And what I can prove to myself is that the Earth is not a globe and it's a level plane.
Subjective.
No, objectively, I can prove that.
Whoa! So it's objective if you can prove it to yourself.
Yes, if you could prove something to yourself, then it's objective. If you could specially repeat it, because that falls under the scientific method: measurable, testable, and repeatable. For example,
because you're proving all the ways.
For example, like a car engine is not a theory; it's reality. It's
well, because we've created it.
Yes, now we can replicate it and create another engine and another engine. So that falls under the scientific method. Exactly. We can test it, experience it, and use it. Gravity, on the other hand, as a pulling force, doesn't exist objectively. It only exists on paper. They only show us equations about gravity, but they cannot manipulate gravity or use it, for example, because it doesn't exist practically. However, buoyancy, you understand buoyancy, right? Like, that can be used practically. We can utilize buoyancy. We can recreate buoyancy.
Now, how? Please talk to me. Talk to me.
Well, look, buoyancy is acting in this direction right now, for example, right? Yeah. If I apply a force in this direction, I can reorientate buoyancy in this direction. Yeah. Using a force, a physical force.
Yeah, but damn, no. I mean, on even bigger levels than this.
Well, this is a very fundamental scale.
Yeah.
But obviously, submarines use buoyancy as well to be able to ascend and descend. They decrease pressure and increase pressure. So all of these instruments are being utilized in all of the, in the real world. The only thing is that they're flipping the script. They're telling us that the force is a pull instead of a push. That's the only difference. Everything else still works the same. That's the thing. That's the big psyop. And I'm going to tell you, that's the biggest psyop on Earth. Ask your dad this. Ask him, do you believe the Earth is motionless or pushing up? I guarantee you 99%, he's going to say the Earth is motionless. Why? Because over 95% of flat earthers, and the mainstream flat earth for that matter, all claim the Earth is motionless. What does that mean? They deny the fact that the Earth exerts a force. So they completely deny that. So they are in the same boat as globe believers, that when you release an object, if you believe the Earth is motionless, then the object accelerates down towards the Earth as well. Because if the Earth is not moving up, then it must be the object that's moving down.
That's cognitive dissonance, because they just don't know about buoyancy.
Well, yeah, but here's the thing, though. The globe Earth and the flat Earth both claim objects accelerate down by some magical force.
Okay. I didn't know that.
That's why the flat Earth and the globe Earth are basically like Democrats and Republicans. So that's why they're controlling this information.
They're both wrong.
They're both wrong. Exactly. Yes.
That's funny shit.
Yeah. So I guarantee you, if you ask your dad, he's going to claim it's motionless, because I'm pretty sure he's falling into that psyop as well, that the Earth is a motionless plane. And every mainstream flat Earth channel that has over 100,000 subs, they're all, in my opinion, are part of the agenda. So they're there, again, they're just like Democrats versus the Republicans. The fact is, the Earth is a level plane because it's pushing up. They actually mock that. So I get more hate from flat Earthers than globe Earthers, believe it or not. So because,
I believe that.
Yeah.
They're the most aggressive, bro.
Yes,
and the globers, they're like, bro,
they don't really care.
Like anyway.
They don't really care as much. But the flat Earthers already kind of they think they're right now, so they're gonna defend it even more. So that's what you would call Dunning-Kruger. I don't know if you ever heard of that.
The Dunning-Kruger effect?
Yes. Yeah. Flat Earthers are going through Dunning-Kruger, and globe Earthers are too, let's be real. The people that defend the globe wholeheartedly, they're suffering from Dunning-Kruger, both of them. I hate to say it. Again, I don't just believe what I'm told. I accept
research,
and I understand things for myself.
Yeah.
And again, buoyancy, even ChatGPT had another guy that's in that I follow as well. There's only 2 channels, by the way, that are pushing this. It's me and another guy. But the other guy, he had a conversation with ChatGPT, and even ChatGPT conceded that practically the Earth must be pushing up as well, because the pulling force of gravity just goes against all practical physics. And even ChatGPT conceded. Now, it's only a matter of time, in my opinion, before they rewrite ChatGPT or reprogram it to actually go against that, in my opinion, because right now it concedes that. But eventually they're gonna, again, reprogram ChatGPT to be able to say, no, it's actually a pulling force and it's not pushing and blah, 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 blah. But just some food for thought, you know what I'm saying?
Man, William, this is really cool. I do want to say I still don't really know like the point in terms of like what this is going to mean on a grander scheme. Like if people accept the push of Earth as opposed to, because I think more than anything, man. By the way, please put me onto your YouTube.
Yeah, I think you get my flyer. You can check it out after. But here's my channel. You can take this with you.
Thank you.
Inside are the 6 top proofs that debunk the globe. If you want to give them a quick read. Inside, yeah, the 6 top proofs that debunk the globe. On top of the number 1, which is the gravity is not a pull, is a push. That's the number 1.
Okay.
So
I want to say though. I want to say. No, please. What?
No, go for it.
I want to just say that I want to see you knowing this. Like I want to see how we can transmute, right? Like buoyancy, this concept of like buoyancy on larger levels. You know what I'm saying? Like I don't know. I think it's beautiful.
Well, helium balloons, not helium balloons. Weather balloons, or what do you call those? People get in a little basket and then
the
hot air balloons, right? they rely on the principles of buoyancy as well. I mean, hot air rises.
Lighter.
Yes,
Yeah,
exactly. And again, it relies on the force of the earth acting in that direction. You know, because again, it's the air that's able to push up that balloon, because that air is less dense now. It's because it's warmer. So air expands when it's warm, which means it becomes less dense. So again, even that, like, if I was to ask you, like, what do you mean by like a bigger scale, buoyancy in a bigger scale, like, because those are obviously bigger scale, you know, instruments that utilize buoyancy, obviously.
Okay, so let me first ask, how far does your work go? Like, okay, you're doing YouTube and stuff, but what other ways are you disseminating your work?
Well, this is the #1 censored subject online. I came across this almost 10 years ago when I was 24. I'm 33 now. And by far, on top of any other subject, is the most censored subject on Earth. Literally, what the Earth actually is, the shape of the Earth. It's the #1 censored. That's why nobody talks about it. The mainstream completely just puts it aside, and they don't even talk about it, because that's how censored it is. People don't even want to touch it. It became so censored that it's taboo now. Most people just feel uncomfortable talking about the shape of the Earth nowadays. I mean, that's how, in my opinion, that's part of the social engineering. So it's part of an agenda to make it taboo so that people don't even talk about it. Because, again, a child can understand the principles that debunk the globe Earth. Okay. Then another one, a quick one that a child can understand as well. Do you know the radius of the Earth, they tell us?
Go ahead.
The radius is 3,959 miles. That's the radius, right? And if we multiply the radius times 2, we get the diameter, right? Which is completely across. Now, if we multiply the diameter times pi, which is 3.14, then we get the circumference, which is the whole area of going around the Earth one time, which is 24,901 miles. That's the size of the Earth, they tell us, in circumference, right? Based on the radius and the circumference that they're telling us the Earth is, there has to be curvature every mile. And every mile, that curvature has to be
I've heard this argument.
Yeah. Mm-hmm. So there is a simple calculation. You heard of the Pythagorean theorem, right? A squared plus b squared equals c squared. Mm-hmm. Using that simple calculation, we can determine how much curvature there should be every mile. Mm-hmm. And using that calculation, it shows that there should be 8 inches per mile squared. What that means that in the first mile, there should be an 8-inch drop. Second mile, there should be 32 inches of curve. And by the third mile, there should be 6 feet of measurable curvature, right? So how do we measure for that curve, right? There's a very, very easy way to do that. So if we went to a giant lake that was miles across, for example, and we build a level surface on top of it, like a bridge that was exactly, horizontal, perfectly horizontal, above the body of water of the lake's gonna show that it's gonna be parallel to anything that's horizontal above it, because that's what water level means. When water's contained and at rest, the surface of water always forms a horizontal surface. It always forms a level surface, and level being horizontal, right? That's a fact. And you can demonstrate that with water at any scale, right? Now they're trying to tell us, the globe Earth, that no, water level means curve. There's gonna be a 6-foot drop in 3 miles. So this is what the lake should be doing if it was a ball, but this is what it actually does in reality. And it doesn't matter the distance.
I don't know. Just on that, I don't know. I think it's hard to debate that because we do have mountains and valleys. And,
yeah, but the surface of water doesn't zigzag. The surface of water is always an equal surface once it's contained. Would you disagree with that?
Like with the oceans, like oceans, for example,
oceans
those big ass bodies of water.
Yes.
Yeah, I don't know, but even the then you also have the surfaces, like meaning you have you have land under the water.
But that doesn't make the water on the top. The water on the surface doesn't display the topography of the bottom.
Yeah, but bodies of water also what do you call it? Deposit like into other bodies of water too. So like there's like a constant.
Sure, like rivers, for example. Rivers, yeah. Well, rivers I would say they're on a slope. They're on some kind of like a depending how many degrees the slope is. And if water flows, it's because it's seeking its level. In other words, Now once it reaches a lake, for example, then the surface of water on that lake, and especially if the lake's contained, the surface of water of that lake is always going to remain level, horizontal. And the lake could be 20 miles across. It doesn't matter. And in 20 miles, there should be, let me see, I have it right here. In feet, in 20 miles, there should be 266 feet of curvature. Think about that. So if we had a level structure that was 20 miles across, the difference in height between the starting point and the end point should be 266 feet. But it's going to be...
From top to bottom?
Yes, like this, for example. The difference in height, it should be 266 feet. That's how much water should be curving. But that defies the physics of water, in other words.
So what I'm saying to you is, like, if these things are so important,
yes,
then we need to then we need to show people why they understand, because like why it matters, because like
yes.
because like okay, right, because that's what I'm saying. That's part of the reason why regardless of the fact my dad, Jacob Israel, like my dad is like he's conspiracy theory. I feel like that's terrible though. I feel like conspiracy theorists right now are like, oh, like you guys haven't been, like, you know what I'm saying, because everything is, you know, but conspiracy theory. But for example, like it matters much more, or like we can see better why we should understand, or why it would matter whether, for example, the Sandy Hook shooting was real.
Yes.
Right?
Sure.
Like there's a reason, there's like, oh shit, if they're willing to make up stories like that, and they're willing to like blah blah blah, and they're trying to emotionally affect us, or whatever the case may be, or they're intentionally terrorizing children, whatever these different things, oh no, we can like see that. But like whether the earth is flat or level or global, what can we really extract from that? So but if we can impose that into other realms and show why these different things matter, and the, you know what I'm saying, like creating projects and stuff, you know what I'm saying?
Sure.
Then that's the type of thing. That's why I asked the question about, is this the only way that you do this stuff? Because bro, I would love to like
well,
show.
I'm gonna explain to you the
The science is beautiful. Everything.
So I want to explain to you the difference between, like, for example, like Sandy Hook, right, being a conspiracy, and the Earth. So they're trying to throw the Earth, the shape of the Earth topic, into the conspiracy theory realm.
Right. I know.
And it's not. I'm gonna tell you the difference between a real conspiracy and then physics, because that's what this is about.
Okay.
So a real conspiracy like Sandy Hook, for example, or 9/11, right?
Yeah.
The fact is, nobody knows exactly what happened. That's the fact.
Yeah.
I wasn't there. I wasn't the ones that started it. I wasn't part of the plans. So therefore, we can only theorize what happened. That's where a conspiracy theory comes in, because now we're theorizing that they're conspiring to do something to us, right? Or to affect us emotionally or whatever, right?
And that was Sandy Hook and 9/11.
Yes. So those fall in conspiracy theories because we can't prove what happened and what the real motive is,
okay,
right?
Go ahead, do it. Because
when it comes to the shape of the Earth, I don't need a theory. I go with physics. Physics shows me, so I can prove it to myself. So it's not a conspiracy theory. It's a conspiracy fact, if anything, because they're definitely conspiring to lie to us about what this place actually is. But it's not a theory. It can be proven.
So I want to give you this. I want to give you something.
So that's the difference.
So remember how they were doing eugenics?
Yes.
And how they thought that they could identify like the race of a person based off of like their archetypal features, like their skulls,
sure,
or whatever,
I've heard
right?
of that, yeah.
So they think that they can solve the identity of a person and know the identity of a person by trying to look within them, or trying to, being within them. But you could really only see who they are based off of what you see and what they give you in reality.
Yes.
So even in what you're doing with this level stuff, right? You're still only doing it within the bounds of looking within the Earth. You would still have to get that bird's eye view and try to see the Earth from the outside, right? So that's why I'm saying it's really dangerous,
sure,
to do this, and we're trying to figure out the relevance, right? Like, what is the importance? So we understand, like, you know what I'm saying?
Well, here's the thing. In my opinion, nobody could get that bird's eye view of the Earth because of what I said, that it limits us, the atmosphere limits us, because obviously the density changes. So here, the highest, in my opinion, we've ever gone is around 20 to 25 miles up in the sky. So these images were taken using a giant helium balloon. They're like a weather balloon, for example. And this is like the limit that they go. Obviously, because of the density of the air and all that, they pop eventually. But this is over 20 miles in the sky. And how would you describe the horizon?
Beautiful.
Exactly, beautiful. But geometrically, how would you describe it?
It looks kind of level.
It's level. I would say it's horizontal, which is another word for level. Sure. Yeah, horizontal is another word for level. The only place you're ever going to see curvature of the Earth, again, like I said, is through NASA images like this, which are obviously CGI, they admit it.
And they've already made
or
multiple times.
You're familiar with the GoPro lens, like the fisheye lens from action cameras.
And that's not even fair. And
so
lens corrected, that's not even fair. I don't think that's fair.
But here's the thing: if you use an action camera and you go like a lot of people that go skydiving, for example, they use a GoPro, and they claim that, oh, look at the curvature of the Earth.
No,
it's literally a fisheye lens. It's just a lens effect.
Yeah.
If you were to take your camera phone, for example, that doesn't have a fisheye lens, this is what the horizon is going to look like, regardless of altitude. Here's another thing that's physically impossible on a globe. The horizon appears to rise with you in front of you when you elevate. So if you were in a helicopter and you start to elevate, the horizon rises with you. If the horizon was truly bending down away from you, when you elevate, that horizon should stay fixed, and eventually you'll start to look down at the horizon.
Well, is that not what happens, though?
No, the horizon is always in front of you, regardless of altitude.
Oh, but doesn't it kind of depend on how high we go though too? Because I mean, you can be from a plane. The horizon looks different from how it looks from the ground.
So for example, when the sun is setting right below the horizon, right, and you elevate up, technically, if the sun was going down over a curve, when you elevate, you should start to look down at the sun. Nobody looks down at the sun. Nobody. So when you elevate, the horizon and the sun rise with you. It's all due to perspective. So the horizon is the limit of perspective. It's how far we can see. So
is the sun rising or setting?
The sun doesn't rise or set. It just moves across the earth. And the reason why it appears to set, again, is because we have a limit to how far we can see. And eventually it appears to go over the horizon. But it's just moving away from us. So it doesn't go down or up.
This is awesome because I want to give you another question too.
Yes.
How do you explain then the revolution? Remember you were talking about...
You guys can give this a read if you want.
Because again, we have the...
this one I'm talking about.
Because remember, we have the horizontal nature of the horizon and everything.
Yes.
And you were making the point about China being on the other side.
Yes, if you believe the Earth is a ball, yeah.
Oh, so then tell me your thought processes on that then.
So everybody's on the same level. China is just across the way. So the oceans are like giant lakes, for example, and land obviously is just spread out. It's not around the ball. So the land doesn't bend around the ball. So it's just a level plane, and all the continents are just spread out, and the oceans are just like a giant lake. That's the reality. That's why I say everybody's up is the same. China and Australia don't have a different up than we do.
Yeah, everybody's up is the same.
Yes, exactly. Because orientation is singular, but they're trying to tell us that orientation is relative.
But do you believe still in the revolutions that the Earth revolves?
So you're saying that the Earth is spinning?
Like the Earth spins?
So the spin of the Earth has never been physically measured either. Just like the downward force of gravity has never been measured, the spin of the Earth has never been measured either physically. Because there should be instruments here on Earth that could measure that spin, but they don't.
So I gotta ask you, bro. Do you play Minecraft? You ever play Minecraft?
So a lot of people like to compare this to Minecraft. Like, oh, a lot of people make this claim, which I don't go with, that the Earth is an infinite plane. Just like Minecraft, you could just go infinitely, and then the program just generates more
chunks.
Yeah, exactly. A lot of people like to claim that that's what the Earth is. A lot of flat earthers, but again, these are the motionless flat earthers, the ones that falling into another psyop. The fact is, the Earth has a limit to how far you can go. Where is that limit? I don't know. Maybe the government have found that limit. So am I
debunking flat Earth theory, basically? So most people who believe the flat Earth is fake, because there's been a lot of controversial stuff recently. Just recently, one dude told me that the reason why a lot of people believe fake stuff is because one person a long time ago says it, and most people believe it is. Like, for an example, one person actually told me, and this is very controversial depending on who you are a lot of ways. There's one person who said, right, that Jesus is not actually the Son of God. Someone just made that up, and that's what is contradicting a lot of people. So you know what I mean? Like, there's like a lot of fake stuff that a lot of people say that can sometimes flip the script on what you're basically saying is.
Yeah.
So like, for 9/11, right? Someone like me who's Pakistani, especially who comes from northern Pakistan, people believe that Osama bin Laden is not dead. People believe he's still real because people think like they put like a doppelganger.
That's a conspiracy
version
theory.
Of him. People think they put a doppelganger version of him, and then these white YouTubers who go all the way over there, they try to tell the oh no, like it's actually real. Like they try to dive into this mindset. So that's actually really interesting. What you're saying is. It's actually also interesting because I kind of met you almost a year ago.
You look familiar. I was going to say you look familiar, so I'm glad that you remember me.
Yeah, but it's actually funny. It's actually funny because when I met him, right, I was not even a UCR student because I went to RCC. Now I'm a transfer, so I'm finally here. So now it's more impactful hearing him now because when I used to go to RCC, I was like, bruh. My main reaction was, bruh. I'm never going to see this dude another time in my life. Until now, I'm fine.
Yeah, I'm not going nowhere. By the way, I'm the only one, and trust me, if there was somebody else doing this right now, I would know about it online because obviously there's communities that form and people share stuff. I'm the only one right now coming out to do this, to push that the force of the gravity is a push, not a pull. That's how censored this is. And it trips me out, believe it or not, that I'm the only one. It's like, what the fuck? This subject has been out for over 10 years almost. How is it that I'm the only one actually trying to push this forward? Like, and that just shows that people are just afraid of the ridicule. A lot of people don't have the social skills They don't have the articulation to be able to explain this. So there's a lot of things holding people back, and a lot of bullying as well.
True.
So a lot of people understand where I'm coming from, but again, they just don't have the way or the means to be able to do what I'm doing right now, which I get it. You know, we're all in different stages of our lives, you know, and again, some people are more social than others. I'm actually very antisocial, so I had to come out of my shell to do this, you know. You know, I sit in the back of the classroom. I used to sit in the back of the classroom. I avoid conversations. I don't even like getting a haircut because I don't like, you know, the small talk and stuff. That's how antisocial I am. You know, point being is that I'm having to come out of my shell to do this because online, this information is not going to go nowhere. All of the algorithms from YouTube, Twitter, Instagram, TikTok, all of the algorithms are controlled. Because all of these platforms are owned by the same entities.
They've been controlled.
Yes.
Damn, for so long.
Yes. And they control narratives, different narratives. And this is the number one narrative they're controlling.
Interesting.
So my channel is just stuck now. It's not going to grow anymore. Especially since I started talking about the push of the earth. I started talking about the push of the earth about 2 to 3 years ago. Because I used to just push water as the number one proof. Water being level. And as soon as I started talking about the push of the earth, going against motionless flat earthers, bam, I started getting attacked by flat earthers, shadow banned. Not necessarily shadow banned, but like just completely, my channel doesn't get recommended at all, like whatsoever. The algorithms, exactly.
There's technically a reason why your channel does not get recommended, because technically what YouTube sees as you promoting something that in your light is good, then other people's perspective is negative. It could contradict the algorithm, because coming from someone like me who's a computer science major in cybersecurity, you know, these algorithms, they kind of mess up, because trust me, there's like YouTubers right now that have like 10 million subscribers, like literally 10 million subscribers. And now when they make a video, they only get 200,000 subscribers.
Yeah,
so
we've seen that.
It's almost like the algorithm doesn't care about their content anymore and goes to that one shiny new tool or the next shiny new thing. So technically, if someone said that there was a flat earther, right, then everyone's going to be like, oh no, forget about what this guy said. We're going to go to the shiny brand new thing that's across the block, and we're going to say, okay, this is the thing that we're going to do it. Now, YouTube, for some reason, are having pretty good intellectual conversations. You're talking about how, you know, the Earth is in an actual physics sense, and you're also talking about the controversies, the stuff that, you know, the theories that kind of have a lot of ways. And you're talking about stop the hate and actually preaching for something that's really positive.
No, I'm just interacting with my guy here. Look, yeah. This is I got this shirt from a Bridge Builders Foundation. I'm a part of a nonprofit.
Okay.
But that's actually what I'm saying is, because the truth is, you wearing that shirt is actually proving people's point that people should be following that movement too. Because the reality is, there's so much hate, so much violence, so much problems around this world. I kid you not. People could go on social media, talk about the dumbest thing in the world, and then they get beat up in the streets because they said something dumb.
If anybody knows that, I know that, Yeah,
100%. Because just like you said, right, you posted a video, then your light is really good.
And you
but at the end of the day, and people attacking you because something that you love, something that you represent, is obviously going to come with negativity.
Yeah, but notice. I mean, you gotta. I mean, it's a little symbol right there on the chest. But you guys wear solid colors. That's why I wear solid colors, bro. I don't like having shit on my shirt, bro. Like,
I don't like to identify as anything.
Yeah, like,
that's me right there.
This is also me being a transfer student. So I bought this, right?
Nice.
Simply because I only live 5 minutes away from this campus. Because I only rep my campus when I'm at home. I don't rep it here because think about it. This university thinks of you as dollar signs. It thinks of you as money. And that's the truth is, if you rep something that is constantly just going to giving you money. Okay, have you guys ever heard that college students are becoming more broke like that?
Oh yeah.
Because the amount of money that we spend, the amount of stuff that we do. So that's why sometimes, and honestly, don't you guys hate these people who rep you know, these university shirts but never go to this university? That's the dumbest thing. I've seen people rep Harvard stuff.
Harvard and Yale, Stanford.
Yeah, that's what I don't get. And not even people. It's not even people that do that. For some reason, Lil Pump made an album said, I drop out of Harvard. Bro, you never even been to Harvard, bro. Just dropped out of high school back in freshman year, and bro said, oh yeah, I graduated from Harvard. Bro, you got the lowest GPA in your entire class, bro.
Yeah, but we've seen, out of what you're saying, right? Like, we have seen that, I want to put it this way. You've said the things that you've said and articulating the science behind, you know, again, how all this works. And there are implications, you know, that can be made on various levels, and all that is projects. You know what I mean? And so, like I said, I'm definitely going to check you out. I'm definitely going to see more of this. And if you'd like, man, like I'd love to try to communicate with you to get you, because like I said, people may not understand, for example, the relevance behind, again, the shape of the earth, but they can benefit from understanding the science behind how this stuff works, and then how, you know what I mean? Because I mean, even from you starting from the perspective of, you know, again, something that's less dense, or things that are less dense are going to gravitate toward things that are less dense, or that they don't really revolve around things that, you know, are not like that, or of a heavier density. There's different like relationships in there, like, and again, right, we're talking about like relationships and like relativity. So, you know, knowing these things, having these things, we can really help to fortify people's knowledge and wisdom and understanding and stuff like that. And people would definitely open up to that and hear that and want that. And you can have, again, that's the whole, you know, well, the stem of this is because of the perspective, understanding the levelness, the levelness of the earth and stuff like this. Blah 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 blah. This is what it, you know what I'm saying?
You're literally explaining it very well, because it's not about the shape of the earth.
Okay. Yes.
It just so happens that was pushed. But it, like you said, it's about understanding the principles and the instruments, how they work.
Yes.
Right?
Yes.
Exactly.
Yes.
So real quick, again, talking about instruments, everybody's smartphone has an accelerometer inside of it.
Yes, it does.
And then obviously that's how you're able to put it into portrait and landscape, because there's an accelerometer in there.
Correct.
So that accelerometer in your phone detects acceleration, or detects the presence of a force. So I actually have a video, but I'll just explain it. When you hold your phone and you have an accelerometer app, right?
Yes.
And you have your phone at rest, and you accelerate in this direction or in this direction, or even down or up, no matter what direction you accelerate it from being at rest, that accelerometer registers that force. It increases from 1G to 2, 3, depending how much force you apply, right? In any direction. When you apply a force, it registers that. However, when you have it at rest like this and you release it into free fall, guess what happens to that accelerometer? It registers 0. So it goes from 1G to 0G. So it's not registering any force in free fall. The force only comes back once it makes contact with the earth again. Again, showing that it's the relationship of the earth physically being in contact with the cell phone that basically gives it the force. So it's only when it's connected to the earth like this, at rest, it registers 1G or force. When it's in free fall, it doesn't register a force. So even our you know, our instruments, like our cell phones, don't detect the force. Just like the matter that I showed you with the bottle that doesn't react to a force in free fall. Everything shows that the force of the earth is up, not down. And there is no such thing as a pulling force.
Yeah,
that's why
man.
gravity is just a theory. That's why, you know.
And that's why, again, I was saying from the beginning, I totally, like, again, the whole conversation surrounding gravity, the nature of the atmosphere, I'm like, yeah, it's about, like, relations. Like, I understand I understand what you're talking about in there. And yeah, there's definitely things that you could do with that that would help increase more people's understanding, like how they can navigate through life, right?
Yeah.
How they can, you know, because yeah, you know, again, like with YouTube, everybody's saying, like, you know, there's a very intellectual conversation that's going on YouTube. People are appreciating those type of things more. So knowing that this is the truth, or knowing that this is the case, yeah, there's more ways to definitely branch out with this, and I want to be a part of that type of stuff, because it's the type of stuff that I do, right?
Yeah.
Helping people to understand things in a multitude of ways, right?
Yeah.
Because things are nuanced.
Yeah.
So yeah, well, like I said, I'll definitely check you out. I appreciate you being out here.
No, yeah, no worries. So just a question before you leave, I guess. I know you're not 100%, you know, a globe believer, but if I was to ask you, what would you say is like the number one proof that makes people believe in the ball of Earth, or maybe made you question that it could be a ball? What's the number one proof? Why do you contemplate that it could be a ball, I guess, or maybe if you do believe that it's a ball?
Yeah, bro. Like, I don't.
You don't? Okay.
I don't contemplate whether it be a ball or level or flat, because, like I said, I just don't think it's important.
Okay.
Like, it might be now. Don't get me wrong. There are universal truths, right? Like, we know, for example, like, what's a good one? That like, for example, like male and female biologically are, you know, they have anatomic.
Objectively, there's a difference.
Right? But, you know, not everybody's having sex, or not everybody even plans to have children, or
Sure.
not everybody, you know, or whatever. So, you know, but just because they make those decisions, it doesn't mean that they don't understand, or that they can't understand the anatomical capacity or potential between the male and the female.
Yes.
So you can understand that. So, but and I guess you can always, again, like rely on that as a universal truth, that like at some point. But beyond that, Like, yeah, because that's what it would be. That's what it would be when I go and I and like we go and like we created an experiment to show buoyancy on like a grander level that really like touches like human consciousness.
You know what?
Then the only thing we'll have to fall back is being like, well, yes, the Earth is level, and this is what allows you the opportunity to behave in this way, and that's really it. Like,
yeah, it just hit me. I did a buoyancy experiment. It's like a minute long. I want to show you because you made a good point there about like people want to see buoyancy like, you know, working. And here, let me just show you real quick. Here we go, experiments. Okay.
Because like you even said, that's what I was saying from earlier too, like you even said like matter can't share the same space. However, we have noticed that we have different matter in terms of even like molecules or atoms and stuff like that. So they can merge.
Sure.
Right?
On a molecular level, sure. Like,
yeah.
Here, let me just show you guys this.
Please.
So here's an experiment I did. It's on my channel. You guys can check it out after if you want. But look.
A slinky will only stretch when there is a force being applied. You can test this for yourself. You cannot stretch the slinky without a force.
Yeah, that's true.
I was gonna say, do you guys agree with that? Yeah, right. A slinky cannot stretch unless there's a force being applied to it. Exactly.
Important to note, as it will make the following experiment much easier to understand. When we have a bottle with water, when it's connected to the earth, we can experience weight and buoyancy, which are effects of a force or motion. For example, something that's more dense or heavier than the water by volume, like the slinky, will sink or appear to go down.
Yep.
And something that's less dense, like the ping pong ball, will get pushed to the top or float.
Yep. Exactly.
If I glue the ping pong ball to the top of the slinky so it can be one unit, we can experience a density gradient. The more dense material at the bottom,
That's fire.
and the less dense at the top.
But that makes sense though. That makes 100% sense though.
Yeah, exactly. But here's the thing. Look what happens in freefall.
Slinky's being stretched shows that there is a force present when connected to the earth.
So the fact that the slinky is being stretched shows a buoyant force. You can clearly see the buoyant force stretching the slinky. Because again, the slinky is not stretching itself. It's being stretched by the ping pong ball.
Yes.
Because the ping pong ball is undergoing buoyancy.
Yes. Relationship.
Right? Yeah,
yes,
exactly.
However, as soon as I release the bottle into freefall, the buoyant force of the ping pong ball and the weight of the slinky completely vanish along with the density gradient. The slinky is no longer at the bottom, and the ping pong ball is no longer at the top. Also, the fact that the slinky is not being stretched shows that there's no force present.
The force of
Acceleration requires a
everything
force.
weighing on
No
top
force
of
in
it
freefall
kind of
equals
condenses everything.
Well, that's the thing. There is no force in freefall.
Yeah,
That's it.
there's no force.
There is no force in freefall. But I know the globe Earth explanation would be that everything's accelerating equally. So that's why the slinky doesn't stretch. So they say that
The
gravity
law of
is
motion,
not a...
like Sir Isaac Newton, right? It's basically where the apple kind of fell on his head, right? And when the apple landed down, a lot of people were asking, how did the apple come from the tree and came all the way down? So that was another thing. Is then there was one video that I watched was that if you have
That's good.
just a penny, right?
Sure.
There was a guy who dropped a penny from a New York apartment and
Yes.
dropped all the way down. So the thing is it true that if a penny flies from that fast and that far, can it actually penetrate something, or do you think that's a lie?
It probably could. Could. Here's the thing, though. A lot of people think that difference in speed between the penny falling and the earth, it's the penny accelerating down. But what if I told you that it's actually decelerating? So the difference in speed, the difference in speed between the penny and the earth is actually a deceleration of the penny. So the difference in speed between the earth and the penny is always going to increase. But that's not because the penny is accelerating down. It's because it's losing momentum. So the impact of the earth hitting the penny when you drop it from higher is going to be greater than if you dropped it from lower, because it had more time to decelerate. So my point with this experiment is that a lot of people, especially flat earthers, motionless flat earthers, will say that, oh, the reason why objects rise in water, and it's just a relationship between the water and the ball. So because the ball is less dense, the water will always push it up, right? And I'm saying is that no, the water still requires a force, external force, to be able to push the ball up. And like I showed here.
Shit.
Does that make sense?
Shit. But is it not enough to just simply say that like objects themselves like possess their own properties that make them like who they are?
No, they have their own properties when it comes to like their densities, but when it comes to motion, what makes them move there's nothing inherent in the objects that makes them move. Because when something moves in a particular direction, what dictates that direction that they move?
Force, right?
Exactly. Force has to be external to matter.
Yeah, but you do agree that force is, because you are saying it. But please make sure that I'm understanding this correctly. That the force that you are speaking of.
Time for me to go right now.
Appreciate the chat.
Yeah, what was your name, bro?
My name's Adam.
Adam?
Yeah.
Cool.
I don't know if you checked it out last
Yeah.
time. Did you? But you could take that with you.
I'm desperate. I just put mine in. I'm gonna need another one from you, bro.
Yeah.
I'm desperate, bro. Nice to meet you.
Yeah.
But no, what you call it? Are we in agreement that force is not just
Right.
that force is not just force does not just, you don't just get force from like an intentional force, right? Or like from an autonomous thing. Like you don't have to be an autonomous thing to exert a force. Or like and autonomous, so I'm saying inanimate. Like you don't have to be inanimate. You don't have to be animate to exert a force. Like you can just be your own thing in relation to the other objects that are around you.
Well, that's the thing. That's what they're trying to tell us. But for example, I know where you're getting at. Like, for example, a self-driving car. All right, that will be the closest thing to what you're saying, I guess. Something that's not.
Oh no! What do you mean?
Because what are you trying to say? You're trying to say that something that's inanimate can move itself. What are you trying to say?
Can move itself.
Can something move itself?
But okay, something that can move itself is autonomous, right? Like there's and like that's why even to me, like when you mention like an inanimate object, like an inanimate object is just an object that
it's just there.
It's not autonomous. Like so.
What do you mean by autonomous? I'm sorry, because I'm a little. I'm missing you there.
Yeah. See. So I mean, this is part of my work. So, like, damn, and there's different ways to put this, but so autonomy. An autonomous force, for example, is, or I guess probably the best way for me to put it here is like an interpretive force, like a force that can interpret. So if you have a force that can interpret, there are actually two levels or two planes that it exists on, at least. But there's so you have the first rule of life, which is self-preservation, and then you have the second rule of life, which is compassion. Now you need self-preservation because you are your own object, and you're your own object interpreting and taking in like stimuli and all that stuff. You have to process it on your own. But then you also have to understand that you are on a plane sharing it with other objects that are all around you that may or may not have their own autonomy to it, and which have the same capacities that you have to evaluate your world, right?
Yeah.
And you can't obviously control those parameters, whatever. You may not know where they were from or whatever, but they are still their own beings, and then they have their own they have their own interpretations. They have their own decisions that they make. They have their own circumstances, all that type of stuff, right? Yeah. So if that's the reality, then it has its own essence, and then if it has its own essence, it has its own relationship to the environment or to the other objects that are all around it. So it can be its own thing, whether or not it's, and again, right, like all these things being like objects or whatever around us and yada yada yada. They can be interacted with, so we can all be interacted with, and then these things can help us to move or transcend or transgress or whatever in just like various ways. We don't need like you don't. So that's why I'm so a force is, even in the physics sense, doesn't have to be like a person pushing a thing, right? Or it doesn't have to, a force doesn't have to be like even with the dropping. Like it's like, okay, well with gravity, we can say like gravity is, and then it's gonna say, well, because it's free fall, there's no acceleration, but that doesn't mean that there's no force that is pushing down or pushing down or pulling down or whatever the thing to where it needs to be, because it isn't inanimate if you can at least like drop it.
Well, that's the thing. In my opinion, that would be special pleading, because in every other circumstance, when something's at rest and we apply a force, we're gonna get displacement. Matter is gonna react to that acceleration in every other sense. But in free fall, that's the only place that people say that, okay, there's some special circumstances going on here, but it is accelerating down, even though there's no effects of acceleration.
But what makes us call it free fall, right? Is it free fall because we consciously know that we didn't exert a force on it, or is it free fall because
it's? I don't know. I would say it's free fall because there is no force acting on it, and then we have instruments to be able to measure if there is a force acting on it or if there's not. Like I showed you the two water bottles. One was accelerated down and one was free fall. You could tell the difference between the two because one doesn't show any effects of the acceleration.
So then you don't consider this intrinsic motion to be a force?
No.
Okay.
No. It's what's happening is when you have two objects, for example, moving up at the same time, and one starts to slow down like that, but it's still moving up. From this perspective, this one's gonna look like it's starting to go in reverse.
From that one's perspective?
So like, let's say if you're on a train and there's a train next to you, but then that train they're both going at the same speed. but the train next to you starts to slow down, it's gonna look like that train's going backwards.
Okay, what are you saying there?
What I'm saying is that when an object appears to go down, it only appears to go down. It's not actually going down. It's the Earth, it's you and the Earth that's moving up to catch up to the object that's in free fall.
Okay.
But the object's still moving up. It's just moving up at a slower rate now because it's not being sustained by you and the force of the Earth that's being transferred through you.
Yeah. But in the realm of an autonomous object or an inanimate object and force and stuff like that, like, it is a privilege. It is a blessing that we have the ability to exert forces onto things.
Yes.
But we are also not the only things that can exert force. In fact, we speak to, and that's why, like, even with like gravity, I only look at gravity as like an explanation of that circumstantial thing that does exist in our environment, as opposed to like trying to say that, like, oh, this is like, no, that's not, you know what I'm saying?
Yeah.
But you can't deny that, oh no, there's absolutely a force that is causing, you know, that to happen.
Yeah.
But that doesn't mean that there is not a force. Like, I don't think that, like, we can neglect that just because we are not the ones who are exerting the force or whatever, that, you know, we can neglect the elements of.
I agree. When you release an object into free fall, you have two options. Either the object, there was a force acting on the object to move it down towards the ground, or there was a force acting on the ground that came up to the object. It's one or the other. And instruments show that free fall there's no force acting on an object in free fall. And the same instrument shows that the Earth is exerting a force up. Does that make sense?
Wait, which same instrument?
For example, the accelerometer on your phone.
Okay.
Another thing is, when you know how this ball right now, because it's connected to the table, which is connected to the Earth,
yes,
it's experiencing a buoyant force right now because the ball wants to go up right now. Exactly.
Right.
If I was to put this into free fall, that upwards push is not going to be there.
Yeah.
So there's not
a ball in a free fall?
Yeah, because right now the water is undergoing pressure right now. The water inside this container, it has pressure right now, and that pressure is what's pushing. Again, the word pressure has to do with push.
Yeah.
It's pushing the ball up. When this container's in free fall, the water has zero pressure on it.
Yeah, but remember, so and if the ping pong ball was in free fall, it would go down.
It would appear to go down, but that's because the Earth is catching up to it.
Yeah, that's what you're saying. You're saying. But it would appear to go down. But also without the string, the ping pong ball would float on top
when
of the
connected to the Earth. When connected to the Earth, like I showed with the slinky. When I put it into free fall, the ball didn't float to the top anymore. The slinky retracted.
Yes. Because
there's no forces acting on the slinky anymore. Because that buoyant force vanished in free fall. So buoyancy only exists when there's a force present, I guess.
Yeah, but we were talking about autonomy, right? Like, we're talking about autonomy, so.
I actually have the definition because I wanted to understand what exactly you mean by autonomy. Because when I hear autonomy, I hear like I take it as like, oh, it's the makeup of the body, for example, like your autonomy, the makeup of your body.
Yeah, but would you agree though that because like cows, for example, they have their own lives to live, and they don't have to do the things that they do. They have other things that they can do, and they do make those choices. So they are still autonomous.
Yeah. So I would say that regardless of your autonomy, here on Earth, you're subject to the force of the Earth. Like, you cannot overcome the force of the Earth just because you want to reprogram your autonomy or something like that. Like, the force that makes things move, I guess I would say, is not programmed into matter. Orientation is not programmed into matter, for example, because orientation is what gives us, makes things move. Because orientation requires a force, and force is motion.
Well, we have to be on the same level then. Because orientation, I want to make sure the determination of the relative position of something or someone, especially oneself. So the determination of the relative position of something, the relative physical position or direction of something. So
relative to a force. I don't know if they cover that part, but it's relative to a force.
Yeah, it says the determination of the relative position of something or someone. It says especially oneself, actually, but it says the relative physical position or direction of something. So, but again, orientation, and this one says, so again, like orientation. So like, but you said, science doesn't play into the orientation of matter. That's what you said.
That science what?
Doesn't play into the orientation of matter.
No. Yeah. Orientation, again, in my opinion, it's something that we all experience. You know, we all experience up and a down, obviously.
Right, from where we are.
Yeah. My thing is that you require something that's already moving to give you that orientation. So because the Earth is moving up, that direction of the Earth moving, it's what we consider our up, and opposite of that will be down. So when we have an up, a direction of motion, then relative to that direction of motion is how we get every other conceivable direction. So opposite of that will be down, you know, perpendicular to that will be right or left, you know, and then 45 degrees between those two will be 45 degrees, you know. So every orientation is relative to the vertical here on Earth, which is the force of the Earth. But again, they're trying to say that force of the Earth it's down, it's a pull, but in reality is a push. That's the only thing they switched. That's the only thing they flipped.
Yeah. But if you're talking about talking about inanimate objects.
Yeah.
Like if you're talking about an inanimate object like a ping pong ball, or even like a what do you call those things? An anvil, right? Like
Sure.
the
Yeah,
anvil's going to come down.
Yes.
But
that's because the water's not dense enough to push it, in my opinion.
Word. Well, yeah. Right. And so the water not dense enough to put it, but the water itself is its own contiguous entity, no matter what it is. So like you said, right, like everything has a container.
Yeah.
So then every container has its own properties about itself, and it can be varied simply because of the fact that we just have like a.
Yeah, I know where you're going with this. So
Yeah.
just because something has mass and volume and characteristics and stuff like that, that doesn't mean that now it has orientation. That doesn't mean.
Okay,
that.
talk to me. What is it? What do you mean by that? What do you mean?
So, for example, when water is contained here on Earth and it levels out, that's showing that it has orientation because it's level now, which is perpendicular to the vertical, right? If you was to, for example, right now this water is level, it has orientation, right? It's sitting, you know, at the bottom of the bottle, and the surface is displayed level, right? If I was to shake this water bottle like this and just release it into free fall like that, it won't have orientation until it makes contact with the Earth again.
What? No,
Yes.
I can't agree with that because
I can demonstrate that.
Because it's still water though. Like just because, or like okay, like the classification of something being horizontal or vertical or
Yes.
whatever level, you have to like that you have to name it. You have to identify it as being that thing. Like you have to characterize it as that thing. You
Sure.
have to create the names or. You know,
Sure,
so
we can label these things. Exactly, yeah, we're labeling these things, but they're real. Level is real.
Yeah, but it's still water.
It's
like,
water, yes.
Yeah. And contained within whatever it's contained with.
Yes,
That doesn't mean that it
yes.
doesn't have an orientation. It has the orientation of water. Like it has the orientation of.
That's the thing.
The thing in the container. Like
Yeah,
you know?
again, when water has orientation, it shows you the level. You know, when water is contained. Like if I was to show you an image, for example, of water like slanted on the wall right here on its side. I don't know if you've ever seen like perspective images that people take, for example. They'll sit on a pool, for example, and the water will be underneath, but then they'll invert the image. Now the water looks like it's on its side. Like, you know,
Like
water.
to rotate it, like
yeah, like if you rotate the image.
and shit,
Yeah.
like-
Oh, you know what? Here, I have.
Well, I don't even know
Yeah,
water.
actually, I used to do this question before.
Yeah.
I want to see if you could determine the orientation of these three, the correct orientation. All of these water bottles are at rest here on Earth. Can you determine the correct orientation of these? The water's blue, by the way. I use food coloring. These three water bottles. So which one of these three is in the correct orientation? How I'm showing them to you.
What is the correct orientation then?
Well, water will show you. It's perpendicular to the vertical. Which one's perpendicular to the vertical?
So water is the dictator upon.
No, because water is subject to it as well. Water is experiencing a force in these three containers, but what direction is the force acting on in this one, for example?
Wait. What is water subjected to? What is water determined by as well? Like the orientation of water. What is the orientation of water determined by?
Yeah, so out of these three water bottles, obviously, knowing that the water is blue because I painted the water with food coloring, which one would you say it's right side up? How I'm showing them to you. Which one's right side up?
I mean, it really depends, but this would be looked at as like the way that is right side up.
Yes, you got it. Why does this one look different?
I don't know.
How is, if you could turn it in any direction, what direction would you turn it so it can make sense to you? From your
what do you mean
perspective.
make sense to me?
Because look, I'll make it easier for you. I took a picture of a. Oh, damn it. This wind. Okay, so I took three pictures. These three pictures. I took obviously halfway filled with water. I took one picture like this, which is the one you already got. I took one like this, and I took one like this.
Yes.
Can you distinguish which one
but
is
they
which?
all look like they're on the same surface.
Yeah.
They all.
Yeah, because I want you to focus on the water. The water's going to show you what directions the force is acting on it.
So then, is this because you turned the bottle upside down and
Yes.
made this the bottom?
Yes.
Yeah.
So
yeah.
I actually took it like this, but using a computer, I just flipped it.
Yeah.
On a computer. How did I take this one?
Well, then this would have to be inside of the container, but the container would have to be on its side.
Yes.
Yeah.
Yes. What side was it? Was it like this? Or was it like this?
Yeah, the side.
Yes. Well, how do you know it's this way and not this way? Because you're correct.
Because we know, I'm going to use your words, the connection to the earth.
Yes.
Yeah.
Well, again, water can't stick to the top of a water bottle. That's another thing. That's obvious.
Because it's not less dense than
yes, because because the air is less dense.
Air, yes.
So the water's gonna seek the lowest point, and then the air is gonna move to the top. You know, that's why air bubbles rise.
Yes.
You know, because they're less dense.
Yes.
My point is that water does have orientation, but not because it creates it on its own. It's subject to the external force of the earth that gives it a container, exactly,
Okay.
which gives water orientation.
Okay.
Again, everything that has orientation here on Earth is because of the Earth's push.
But remember, you're saying that something doesn't have orientation when, at least this is how it sounds.
Yeah.
That it doesn't have orientation when it's not still to begin with.
Well, when it's in free fall, if something is in free fall, then it has no orientation because there's no forces acting on it. So if you were in free fall, for example, have you heard of zero-G flights, like parabolic flights that people do? Yeah. If you were inside of a zero-G plane, like when it's doing its parabolic flight, and again, if you were blindfolded, you won't know what's up from down because there's no forces acting on you while you're in free fall. Not until the airplane flies level again, then you can feel the force. You know, obviously, you know, if you're upside down, you're gonna feel the blood rush to your head and stuff like that.
Yeah, but you would still know if you're doing a front flip or a back flip.
That would maybe, but that's because you have to push yourself off of something else to do that flip. But that's because that's a true motion that you're experiencing.
Okay.
But the motion of you accelerating down towards the earth in free fall, that motion is not there because you're not moving down towards the earth. It's the earth that's just catching up. So if you're a skydiver, it's obviously skydiving, a lot of people think that you are rushing through the air, right? That's why you feel the air, you know, in your cheeks and in your hair. Yeah. The reality is it's the air rushing through you.
That makes perfect sense though. I don't think that's a question. But
yeah, because a lot of people would say that, I could feel me accelerating down because they feel the air, but it's like, no, you're feeling the air rushing through you. That's what's happening. So if you have a giant fan in front of you, you're gonna feel the air push your face, right? That's what's happening when you're in free fall. If you're skydiving, the air is just being pushed up, so you feel that.
Okay.
Yeah.
Okay. But remember, we're talking about orientation.
But yeah, orientation kind of went a little off topic. But yeah.
No. But with orientation. So with orientation though, so that's what I'm saying. Like, so even when you have a substance such as water, which or a gas, which takes the shape of a container, right? Then how is the container itself? How does the container not have an orientation? Like, how can the container itself? Because there's still orientation in that. It doesn't mean, and that's what I'm saying. Like, now a container containing something, right? That is also part of its orientation. You know what I'm saying? So that's not a.
Well, let me try to explain it like this. So, let's say we have a container in space, right? It's just floating, and we put objects inside of it, right? Let's say we put water, right? We put a rock, and we put a helium balloon, right? And it's just a container in space, right? Like an empty space, for example. There's no forces acting on it or whatever. What dictates what's up and down in this universe where there's nothing? It's just this container.
Well, first of all, again, I like your starting point, which is connection to the Earth. The Earth serves as it has its own way of being like a calibration point,
yes.
Right? So, depending on the container, which is the water bottle, right? However this or whatever, right? And then it being level with the Earth is the ultimate equalizer, right?
Sure,
then that is what is determining the orientation, right?
Yeah. But what about the Earth that's determining it? What is the Earth doing that's able to give things orientation?
Existing, first of all.
Okay, existing, yes. What else is it doing to give matter orientation?
Existing.
What else besides existing?
Tell me.
It's moving up. So let's say this was the Earth. Obviously, it's not the Earth, but let's say this was the Earth. Or let's say this was the Earth, right? And we have matter just here floating, right? Water, different states of matter. If I was to move this table up, then that's going to determine the orientation now, that motion up. Because now we're going to feel the force not only of the table pushing up.
This is what you're saying. Go ahead.
That, now the opposite of that, the direction of the force, obviously if we use a buoyant object, it's going to show us that, for example, a helium balloon is going to rise up because the air is also moving up, which is pushing up the helium. So because of the motion of the Earth is there, that determines our orientation. So it's not just the Earth existing, which obviously you require the Earth to exist first. You require also the Earth to have motion. And then depending on the direction of the motion, that determines our orientation.
So remember that...
orientation requires motion first. That's the
orientation requires motion first.
Yes.
So remember how we're talking about inanimate objects or non-autonomous objects?
Yes.
Probably liquids and gases are the least autonomous out of all of the objects, right?
Yes, I would agree.
So what I'm saying is, so if you have a mass, right, like if a mass, and especially a solid mass, right, like a table, like the land, like whatever. Yes. Like I said, that's not. I see it as for all those things. It's really relationship because it's built into the thing that it is what it is. Like we couldn't control water being water or gas being gas. As a matter of fact, it is that they possess the properties that they do that allow us to characterize them as liquids or gases or whatever, right?
Yeah.
So same thing with the solids. So that's why again I'm like how is it not enough in the example that you showed with the slinky?
Yeah.
How is it not enough to be able to say that like, well, it's not about I don't think it's necessarily about like, for example, I guess where the motion is coming from or whatever, as much as it is about the actual object itself, like the essence of the object, and that object, because it exists, its relationship in tandem with, you know, the other objects that it's like, because there are other objects, you know what I mean? Like if we could just be our own. Yeah, please.
Here's the thing: if it was just simply a relationship of a solid object, for example, in water and the slinky with the ping pong ball, if it was just simply a relationship of matter with matter, then when I release that container into free fall, that slinky should still stay stretched. That ping pong ball should still be pushed up, and then the slinky should still be in the bottom.
Disagree, because the slinky has a, like you said, right? The slinky itself can't even move without a force being exerted on it. Yeah. So that means that the essence, right, and the slinky's relationship to the Earth and all this type of stuff is this way that it is, where it can't do this thing. It can do this thing, and it can do this thing because an opposite force is acting upon it. But that doesn't take away from the fact that it is a slinky and it has the potential or whatever to do the thing that it does, right? Yeah. And its potential all lies as well within the relationship that it has with things that are here that are here in the same environment that it lives in, right? Because otherwise, if we're not here to as autonomous beings to interact with it or whatever the case may be,
I guess my point is that if it was truly just a relationship of the autonomy of objects and that's what causes orientation, if that was truly the case...
That's not what I'm saying, but go ahead.
Okay, what are you saying? Because that's what I took it as. Like,
no,
there is a relationship of matter that gives it its orientation. Or what gives it orientation in your eyes? If
existence. I'm saying existence. Because like you can only... First of all, you can only determine the orientation of something if it exists, and having the means to observe it. Like, because even there's an orientation to, like, for example, temperature. So like so I can feel that, oh, this is warm air, this is cool air, this is, you know what I'm saying, or it's hot or it's cold. It doesn't need to be a physical thing for me to observe or whatever. It doesn't just have to be that thing in order for me to be able to fathom an orientation of it. Because like orientation is synonymous with perspective.
Well, I would say heat is subject to the orientation of Earth, just like air bubbles.
Absolutely.
Yeah,
yes.
That's why it rises.
Yes.
If Earth wasn't exerting a force, heat wouldn't rise. Bubbles wouldn't rise, helium balloons wouldn't rise either. If Earth wasn't exerting a force.
No, I agree with that 1,000%.
Yeah. So that's my whole premise, is that orientation is subject or relative to the direction of the force. And less dense objects follow that direction.
Oh, beautiful, bro. That is so cool.
Yeah. Again, if Earth wasn't exerting a force, then we wouldn't have up or down. Things wouldn't rise, heat wouldn't rise, stuff like that. And that's where motionless flat earthers, that's what they claim.
That is so beautiful.
Which is bullshit, in my opinion.
Yeah, that is beautiful, man. I love that. Yeah, because I just wanted that clarity in terms of like, well, no, I think things do have orientations without having to be animate object or having to be solid. That's what I'm saying. Like they don't have to be. You can have an orientation without being solid, and you can have an orientation without being animated. But no, definitely, I definitely can concur and concede to that whole idea that, well, if we could see all these other in terms of the intangibles, right? With the forces, gas rising, all that type of stuff. There must be a force, like there must be, and there is.
There is.
And it can't be, but it also cannot be ignored that us being other objects that are in the midst of all of this, right, and having the ability to interact, that does not dismiss the fact that, or that doesn't have anything to do with the fact that we all have our own relationships to the things,
yes,
and that they can be their own things without having to, intertwine them with other things. It's just I hate to say this, but it's only happenstance that like certain objects not only have higher or lower densities in relation to other objects, but also that our Earth moves in such a way, right, where it takes these things into account, and sorts the environment.
So the matter's not really sorting itself, I guess I would say. It's more or less happening because, again, it's the medium that surrounds it. Is it dense enough to push it up in the direction of the force? If it's not dense enough to push it in the direction of the force, then it's going to displace in a downwards direction relative to us. If something is less dense than the air, for example, and there is a force present, then the helium balloon's going to rise. So yeah, it matters the density of the object, what direction they're going to appear to move, but they're not moving themselves, is my point. So a helium balloon doesn't rise.
And that's fine.
Yeah.
That's
it's all subject to an external force. That's my point. The orientation of matter. It's all subject to an external force. That's what it comes down to. And that force of the Earth is a push, not a pull. Because they're trying to tell us, gravity pulls everything down towards it, but helium goes against that force. And it's like, well, that goes against physics. That doesn't make any sense. Helium going against the force. If the air is truly being pulled down, think about this. If the air is being pulled down, how can the air push a helium balloon up if it's being pulled down? If the air is pulled, it doesn't make any sense. It's just an explanation that they give.
This is where we were at, again, from the beginning. Again, like I said, the relationship. I don't think that's. I don't think it's more or less about, because again, right? I mean, like you said, like defying physics. Yeah, but like people try to defy English, or they try to defy their own fucking sexual makeup, like their own whatever their they try to defy these things all the time. And yeah, we try to push those boundaries, especially to try to like find new answers or new. But I don't think that, like I said, just because an object has the properties that say that it is of what we call being less dense, right, that pushes it in an opposite direction. However, I'm sure you could word that so much better than I could, but to push it in the opposite direction of what we're accustomed to gravity actually being, like I feel like that's relationship more so. Like, I don't think that's like I don't even think that's an attempt to defy physics. Like I think that's just again the relationship. Like, I feel like that's the essence of the object is just that thing, and then it's those properties, it's those characteristics. It's a blessing we can even explain.
Yeah. Well, like again, like the helium balloon in the van, like I showed you. This ball in water, again, we could do different scales, different states of matter. A buoyant object will always move in the direction of the force, always.
Yes.
And that's the thing, and what they're claiming gravity is doing is the opposite of that.
And
that's special pleading.
Can you help me be clear on the definition of buoyancy?
Buoyancy, in my opinion, is a chain reaction of a force. In other words, if an object is less dense than the medium that surrounds it, it's going to be subject to the direction the force is being applied 100% of the time. Yeah, so that's what buoyancy is, in my opinion. It's a chain reaction that happens. Something pushes this, and then the air pushes this, and then
an object contained inside of a container that is dependent upon the events of
the force container. Of the container, exactly, what direction the container moves. Okay. So the Earth, in my opinion, is a container, and this matter is showing us that it's moving in this direction. So.
Yeah. And all these being inanimate objects, from the container to the ping pong ball to the string to the little popsicle stick at the bottom to the water, all those are inanimate objects.
Yes.
Non-autonomous objects.
Yes.
That are depending upon us to make the motions, on us to do the things, but that doesn't take away from the fact that like they're still their own things that are in relation to the whole thing. Because you keep speaking into the essence of like objects being in free fall, but how much free fall do you have when you have all these boundaries that the Earth creates, right? Like we can't live in the free fall and stuff like that, right? If there are absolutely boundaries for the things to meet, you know what I'm saying?
Yeah.
So if there are boundaries for the things to meet, then it's only necessary then that we have to give consideration to the fact that there's relationships, like there's like the relativity of each individual thing in relation to the Earth. Yeah, there may be forces, there may be like different things. But I don't, like I said, I don't think that a lower density equates to like a lower density and thus, you know, a different direction or a different like journey, a different orientation of an object, as opposed to how other objects are that like defies physics. If anything, I feel like that puts on display the multitude. You know what I'm saying? Like that puts on display the abundance. You know what I mean? In the earth, the various things that we can discover, the various things that we can, you know.
Sure. So I would just leave it with this. Just make one final point before you go. Again, 9.8 meters per second is the alleged acceleration in freefall. Again, if we put that into perspective, 32 feet per second will probably be from that pole, probably close to that pole, from this pole to this pole, probably about 32 feet, right?
Yeah.
Now imagine this container, right? If I was to accelerate it from there to there in 1 second, do you think that ping pong ball will react? In other words, do you think it'll get pushed in the direction?
Yes, of course.
Obviously,
yeah.
Obviously, if I do 4 feet, which is the length of this table in 1 second, it will still do it, you know, easily. It's gonna react, right? Now, if I was to accelerate 32 feet down, actually accelerate 32 feet down, do you think the ping pong ball will react and get pushed down? If I was to accelerate 32 feet in 1 second down, physically?
If this were to accelerate?
Yes, like I showed you in the...
And again, in free fall?
No. If I actually accelerated it, it's obviously gonna displace, like I showed you with the two water bottles I had next to each other. I'll show it again. This one, I accelerated down probably like 5 feet in a second. Maybe, you know, around there. Imagine if I accelerated 32 feet in 1 second, that force will be even greater.
Stronger, yeah.
So the ball will even react even more, right? In free fall, however, they're claiming that same acceleration, 32 feet per second, which is 9.8 meters, without any of the effects. So this clearly shows us that there is no force accelerating matter in free fall, because if there was a true acceleration of 32 feet per second, then matter will react to that acceleration, but it doesn't. So that's how we know, that's how I know that objects in free fall don't accelerate down.
So, but is this falling in free fall?
Yeah, this is free fall. The one on the left. The one on the right, I actually accelerated down with my hand. So I had a bottle like this, and I did this. Even when I accelerate, the water displaces up. You can see that.
Well, I wonder why we can't see the fall. Like, why can't we see the falling of the container? I can't see the falling of the
Here
water
it is.
container.
I didn't zoomed out. And I have a whole video on it as well on my channel. You can check it out after.
Oh, I'm gonna check out your YouTube for sure.
You can see when I release it, you know, my hand's moving up because this is actually supposedly going down. But yeah, no reaction whatsoever. This one actually did accelerate now, and we see the reaction. So my point is, again, even the globe Earth will admit that obviously orientation is subject to a force, right? But they're claiming the force, you know, it's a pull of gravity, right? That kind of force doesn't exist. A force that can accelerate this container without the reaction of matter doesn't exist.
So would you be content? So would you be content with because globe thinkers do not think that do not deny density.
They don't deny density. Yeah, they don't deny density.
So do you think that? So do you think?
I don't deny it either, but I feel like it's just the densities itself doesn't determine what direction they're gonna go. Just because something is less dense than something.
But are you not saying that that's because you're saying that it goes up? So you're saying that doesn't that dictate? Because that's what you're saying.
Yeah, because the Earth is moving up. Like I said, if the Earth wasn't moving up, then nothing would rise. Literally, nothing would rise. Everything would just be. We'll be probably floating too. So the Earth we wouldn't be stuck to the Earth because the Earth wouldn't be constantly pushing up against us. So we'll be able to jump and fly and stay up there. Put it that way. If the Earth wasn't moving up to catch us up again.
So, and again, this will bring us back to the heliocentric versus geocentric argument then too, because I'm wondering if you speak to this.
Yeah.
What do you think is the central point that we are all anchored to then?
I don't know. That's a mystery. A lot of people think the North will be the center point of the Earth, but in my opinion, I think there could be multiple center points. It's not just one, in my opinion. So a lot of people, it could be. That's what I think.
That's fair.
There could be different civilizations in different points, in other words.
True.
Yeah.
William, it's been an honor to meet you, bro. Thank you for educating me today.
No worries, man. Appreciate the chat, man. It was great.
I'll check you out, okay?
Yeah, definitely, man. Appreciate it. Take care.